Studies Section 2. Definition and Scope of Statistics. Introduction. This lecture will examine the definitions of statistics, its scope and limitations, and its importance to political inquiry. We will also explore the branches of statistics and their interrelationship, and then go ahead to define and explain some basic concepts in statistics. Objectives. After this lecture, you should be able to 1. Define statistics as a tool in social science studies. 2. Identify the uses and limitations of statistics. We will also explore the branches of statistics and their interrelationship, and then go ahead to define and explain some basic concepts in statistics. Objectives. After this lecture, you should be able to 1. Define statistics as a tool in social science studies. 2. Identify the uses and limitations of statistics. 3. Define some basic concepts that are relevant to this course. Pretext. Answer the following questions before you proceed to study the lecture. 1. Statistics is concerned with A. Calculation of mean, median, and mode. B. Computation of regression and standard deviation. C. Collection, organization, presentation, and analysis of data. D. None of the above. 2. Some of the uses of statistics include the following except A. Computation and interpretation of difficult mathematical questions. B. Presenting facts in definite form. C. Furnishes a technique of comparison. D. Simplifies unwieldy and complex mass of data. 3. The two main branches of statistics are A. Correlation and regression analysis. B. Description and analysis of variance. C. Inferential and inductive statistics. D. Descriptive and inferential statistics. 4. The relationship between population and sample is that A. Population is a census while sample is also a census. B. Sample is a subset of population and can be used to generalize about a population. C. Both concepts deal with human beings only. D. Both concepts are unrelated. 5. All the following are sampling techniques except A. Interdisciplinary sampling. B. Multi-stage sampling. C. Stratified sampling. D. Systematic sampling. Content. Section 1. Definition. Statistics is concerned with scientific methods of collecting, organizing, summarizing, presenting, and analyzing data, as well as drawing valid conclusions and making reasonable decisions on the basis of such analysis. Spiegel, 1999. It can also be defined as the scientific study of handling quantitative information. It embodies a methodology of collection, classification, description, and interpretation of data obtained through the conduct of surveys and experiments. Agarwal, YP 1998, P1. It is an analytical tool used in solving problems and in decision-making in areas such as natural and biological sciences, engineering, economics, management, marketing, political analysis, and other problem-oriented disciplines. Branches of statistics. There are two main branches of statistics. They are 1. Descriptive statistics. 2. Inferential statistics. Descriptive statistics utilizes numerical and graphical methods such as bar chart, pie chart, histogram, etc. to look for patterns, summarize and present the information in a set of data. Descriptive or deductive statistics can be described as the phase of statistics which seeks only to describe and analyze a given group without drawing any conclusion or inferences about a larger group. Inferential statistics, on the other hand, is concerned with studying a small portion of a group called a sample and making valid conclusions about the larger population based on the sample characteristics. The phase of statistics which deals with conditions under which inferences is valid is called inductive or inferential statistics. Scope of statistics. Gupta C.B. 1982, in his book An Introduction to Statistical Methods, argued that statistical methods can be useful employed in understanding and interpreting any phenomenon which satisfies the following two conditions. It is capable of being quantified, that is, expressed in the form of figures, either through a process of counting or measurement. 2. It is affected by a multiplicity of causes. That is to say, the changes that are brought about in the characteristic of the phenomenon under study are caused by a number of forces acting simultaneously. Generally speaking, statistics is applicable in all fields where empirical data evidence can be measured and collected. Population and sample. A population is the entire set of existing units being considered within a specific study, usually people, objects, transactions, or events. Examples of population include all employed workers in Nigeria, all registered voters in Oyo State, all distance learning students at the University of Ibadan. The list is exhaustive. The student should think of more examples of population and add them to the three above. A population can be infinite. A finite population is that whose figure is ascertainable, that is, a population that is numerically countable, while an infinite population is that whose figure cannot be ascertained, not countable. Examples of a finite population are the three listed above, while example of an infinite population is the population of all animals in the forest. Variables. Variables. In studying a population, we focus on one or more characteristics or properties of the units in the population. For example, we may be interested in the age, sex, and occupation of a population of registered voters in the 1999 presidential election in Nigeria. We call such characteristics variables. The opposite of a variable is the term constant, which signifies that members of the unit or group have same magnitude of the characteristic of interest. E.g., the number of hours in a day is constant. It is always 24 hours. Sample. A sample is a representative subset of the population. It is a small part of the whole population selected for the purpose of a study. Whatever deductions made out of the sample can be used to generalize for the entire population, provided the sampling technique is not biased. For instance, in order to study the voting pattern of post 311 students consisting of about 3,000 students, I may carefully select a sample of 500 students, study their voting pattern, and then use my findings to generalize for the entire population of post 311 students. One important question may cross your mind: why do we need to select only 500 students, why not study the entire 3,000 students? Well, it is a good question, but read the next section to get the answer. Importance of drawing a sample. 1. It is economical because it is cheaper to work with a sample when the population is large. Assuming the population of post 311 students is 25,000 or more, can we interview all of them? 2. It saves time and energy. 3. Where a population is partly inaccessible, drawing a sample will be more appropriate. 4. Where members of the population can easily be destroyed while studying them, samples are more appropriate. Sampling techniques. The method of selecting a sample is called sampling procedure or sampling technique. The various sampling techniques often employed are simple random sampling, stratified sampling, multi-stage sampling, systematic sampling, cluster sampling. Simple random sampling. This is that technique which ensures that every member of the population has the same chance of being included in the sample. This is considered to be the best sampling technique. Balloting is a practical means of using the simple random sampling. If I want to select 10 students out of 50, I can write their matriculation number or name in separate pieces of paper, roll the paper, and mix it properly in a container. Then, I will select one piece of paper from the container at a time, mixing the remaining content after each selection until the desired 10 students are selected. By doing that, I have given all the students equal chance of being selected. Stratified sampling. This method is employed where the population is homogeneous. The population is first divided into subgroups or strata, and thereafter samples are selected randomly from all the strata. Multi-stage sampling. This technique involves selecting samples at stages, say first stage, second stage, and third stage selection. At each stage, a suitable sampling technique is employed. Thus, in carrying out a survey on Lagos State, one could select only 5 out of the 20 local government areas in the state at the first stage. At the second stage, we may choose few words out of each of the 5 local government areas, and if desired, the selected words could further be subdivided into smaller units for the third stage selection. Systematic sampling. This is concerned with the selection of every nth item from the list of the population. For instance, if we wish to select 40 people out of a population of 100 people, we first numbered members of the population serially. We may start from the first person and thereafter select every fifth number progressively until the desired sample size is achieved. Cluster sampling. This method can be employed where the population is heterogeneous. The entire population is subdivided into clusters and a suitable technique is used to select samples from each of the clusters. Statistical data. Statistical data refers to numerical descriptions of quantitative aspects of things. This description may take the form of counts or measurements. For instance, statistical data on students may include number of students taking a particular course, number of male or female students, number of single or married students, other variables like the height, weight, income, age, or political affiliation of students, etc. Think of more examples. Statistical data can be classified into 1. Discrete and continuous data. 2. Primary and secondary data. 3. Time series and cross-sectional data. Discrete data. This is described as data collected on variables that can be measured precisely, e.g., the number of voters in an election, the number of bills passed by a legislative house in a given year, the number of children in a family. Continuous data are data collected on variables whose values cannot be measured precisely. Their values can only be approximated or pinned to an interval, e.g., the distance between Lagos and London could be said to be 50,007 km plus or minus 1 km. This is not a precise figure but an interval. Primary data. This is the data used for the specific purpose for which it was collected. Its source includes sensors and sampling. Secondary data. This is the name given to a data that is being used for some purposes other than that which it was originally collected, e.g., data collected from Federal Office of Statistics (FOS), World Bank, UNESCO, etc., and used by a researcher in the University of Ibadan. Time series data. A set of observations taken sequentially in time, usually at equal intervals, e.g., bank deposits are often arranged in accordance with the time the deposits were made. Cross-sectional data. These are data recorded or collected at a specific time, usually for a day, a week, or a year. Mode of data collection. Data can be collected using the following devices. 1. Personal interview. Here, the interviewer and the respondent have a direct contact during the process of interview. Its advantages include timeliness, completeness, and accuracy of information. The data collected are original and direct from the source. The questions can be varied to suit the prevailing condition. Its disadvantages include it is expensive and time-consuming. There is the possibility of personal bias. 2. Questionnaire. This is another mode of data collection. Here, printed lists of questions are distributed among intended respondents and statistical facts are generated from their responses. For this technique to be effective and reliable, the following facts must be considered. The questions must not be personal, offensive, or misleading. The questions must be clear and precise. The questions must not be difficult or ambiguous. The questions must be properly arranged. Note that a questionnaire may be self-administered or administered by post. 3. Direct observation. In this method of data collection, the researcher observes the characteristics of interest directly from the population or sample. The population may consist of a set of inanimate objects or a laboratory experiment, or when the desired variable can be measured without soliciting response from the respondent. Importance of statistics. The fundamental gospel of statistics is to push back the domain of ignorance, prejudice, rule of thumb, arbitrary or premature decisions, traditions, and dogmatism, and to increase the domain in which decisions are made and principles are formulated on the basis of analyzed quantitative facts. Robert W. Burgess. Adapted from Gupta, C.B., 1982. 1. Statistics enables us to know how to evaluate published data, when to believe them, when to be skeptical, and when to reject them. 2. It enables us to meet up with the requirement of interpreting the result of sampling, surveys, or experimentation, employing statistical methods of analysis to make inferences, describing the characteristics of a group interpreting a computer printout containing statistical information, or writing up a report based on statistical analysis. 3. It enables us to gather facts, test hypotheses, and develop theories. Statistics further enable us to draw generalizations and make predictions. Summary: statistics as a method is a tool used in collecting, presenting, and analyzing data, as well as the descriptive and inferential statistics. Samples are drawn in order to minimize costs and to save time. Data can be obtained through direct interview, administering questionnaire, and direct observation. The use of statistics makes social science research more appealing, and research outcomes are more clearly presented. This is the end of Studies Section 2. Thanks for listening.